Station 51, engine 27, engine 32, truck 105.
You're listening to The Fire Break with Steve Wolf. Welcome back to The Fire Break. I'm Steve Wolf. As you know, The Fire Break is sponsored by Team Wildfire, where we're working on new technology and tactics to keep people from dying and losing their property in wildfires. I have with me today, be patient with me here, Eleni Asimakopoulou.
Great.
Get that close?
Amazing.
So that's an Irish name, I'm guessing? No,
Greek.
okay.
Greek.
Yeah, I know. All right, just obviously. Right, so Eleni is Greek, so therefore Yasu.
Yasu.
And welcome to the show.
Thank you for inviting me, Steve. Nice to talk to you today.
I used to speak some Greek, but...
Oh, did you? How come?
I had a Greek girlfriend at one time.
Right. I hope that went well.
You know, she didn't speak Greek, actually, but her father spoke Greek, so I learned it to try to impress him.
Okay. Good strategy.
Yeah, right.
Hope it worked.
It turned out okay. So, but I just don't remember. Kalimera. Oh, well. Eferisto.
Well,
no,
good luck.
So this is what happens, as you get older. Not all of it. The stuff you don't use.
Yes,
I'll have to find a reason to use it somewhere. So Eleni, you are a lecturer in fire engineering.
Yeah.
And you're in England now, is that right?
Yes. I've been in many places. So I've started my career in Greece, and then I went to Northern Ireland and in Belfast, and now I'm at Preston.
And now?
At the University of Central Lancashire. So I do teaching on fire engineers and fire leaderships. So first responders and fire engineers in bachelor and master's level. I also do research on various topics. And I would dare to say that I'm not an expert in wildfires, but I have some expertise in infrastructure, how fires develop in buildings, how we can use new technologies to cope with some of the building fires, some crazy ideas that we might discuss a bit later, and doing experiments, and CFD, which stands for computational fluid dynamics. But lately, a recent incident, not so recent, it's been 6 years now, 2018, there was a catastrophic event in my country, Greece, Mati fire, that resulted in 102 fatalities and more than 150 people dying in a single day. So that was an event that really shocked me. And this is where I decided that as a scientist, I need to understand more on wildfires and how they interact with the urban environment. So, in a nutshell.
So that sets you up for very successful research, because I think most people who are successful in something are driven by a personal experience.
Yeah.
And so you, having seen 152 of your countrymen perish in that fire, that lights a fire inside you.
Yeah.
Right. It ignites your curiosity.
Yeah.
And so tell me some of the ways that you've explored that curiosity. You said you're interested in the interface between wildfire and how it spreads in urban environment, and the computational fluid dynamics of studying that.
Yeah.
And you said you're doing some experiments too. What kind of experiments are you working on?
So we're working on small-scale experiments at the moment to investigate how different parameters influence flame spread. So, for example, we have a small fire trench apparatus here that we can change the inclination, And we can also investigate what is the effect of the different fuels burning, what is the effect of humidity, what is the effect of external conditions such as wind. So we can have forced wind and to see how that would influence flame spread, and also to see how some tactics can be efficient. So for example, the use of fuel breaks. So we can do that in a medium scale apparatus, so 1 meter
Oh,
by
wow. That's very high resolution.
Yes, so it's indicative. So it's not a large scale testing, obviously, but we're trying to have some initial data and feed that and try and use that experimental data to validate our software. So we do also numerical simulation of such events. So we need experimental data to make sure that our models work fine. So validation of the numerical code is the first step to really understand the accuracy of our simulations. And when we have this confidence, then we can proceed and upscale our simulations to simulate different larger scenarios with different fuels and different compositions. At the same time, we're trying to build on how to understand how fuels burn. So we do analyze the burning behavior of some typical fuels by performing some elemental analysis such as thermogravimetric analysis. So we burn little amounts of fuel in specific heating rates, and then we can see when is the peak heating rate, what is emitted, what is the heat that is emitted, and we also perform medium scale experiments with cone calorimeter. So we can burn 10 by 10 centimeter surface area samples at various depths, and we understand what is the heat that it is emitted, and we implement that into our safety model and see if this is an efficient way to simulate a specific type of fire. So these are some of the things that we're doing in this field.
That is fascinating. And how do you pick the software that you start with, or did you develop the software from the beginning organically, or did you start with something like Spark? Or
no, we use open source fire dynamic simulator software developed by the National Institute of Standard and Technology, which is a software that is widely used in the fire engineering community. It's not specifically designed for wildfires per se, but there are some functionalities that can be used for wildfire simulations. And these are, for example, you can simulate firebrands like particles using Lagrangian approaches. So there are some mathematical tools that allow us to see how fire can spread in specific circumstances.
And what's the name of that software from NIST?
FDS, Fire Dynamic Simulator. It's a very popular software used in the community, in the fire engineering community, especially for building fires. The majority of the fire engineers that do performance-based design use this software. So it's an open source code. Everybody can download it. Also, there is, the people at NIST, at the fire unit have done fantastic work. Seriously, that was initiated after World Trade Center. So I think you would agree that our field is driven by catastrophes. So
yes.
Then they have made that tool publicly available to everyone to use. And there is an option if you would like to implement your own model to incorporate that into the main code of the software. But there is great support by NIST, and people are really embracing this tool and use it in a lot of applications, including wildfires.
Including wildfire. So which area of your research is the most interesting for you? You said that you're working in about 6 different categories of research right now. Which is the one that you which area do you feel holds the most promise for being able to prevent the catastrophic impact of wildfires?
Well, my main research area is facade fires, and this is what my main research has been on. So how how different circumstances would influence the evolvement of externally venting flames, the building characteristics, the materials, and external conditions such as wind. So I think that the building envelope is a very important parameter that is helping us understand how fire will evolve in later stages. So I find very intriguing how, flame spread and interaction with the wildfires is done through this envelope. Obviously, use of non-combustible materials is something that is widely is an option, but I think now that we are everybody, all the regulations push towards net zero or nearly zero energy buildings, we need to use smart materials, and we need to incorporate different types of materials to ensure energy efficiency for our buildings, if that makes sense. So also we need to consider the building stock that is already out there. So, okay, there are solutions that can be implemented in buildings to protect them in case of a wildfire. But what is happening to the building stock that exists out there? And are there some strategies that we can use to facilitate resilience and help protect those infrastructure? Especially, one very interesting area is natural hazards that trigger technological accidents. So this is another very interesting topic of research. So what is happening to power plants, or how huge facilities can be, which are vital for societal operation, can be impacted for wildfires that are becoming more and more frequent due to climate crisis. And so this is another topic. Also, evacuation is a very important aspect too. So for example, now we do work on a project that has to do with evacuation of high-rise buildings, and how actually fire strategies can be affected by the geometry of the building. So I do believe that first responders and the strategies of first responder is of paramount importance when it comes to preparedness and response. So another, we work on informal settlements a bit, and we have one or two projects in waste fires and also in use of AI tools. So how can we use AI to train? So I did talk to you about CFD earlier, computational fluid dynamics. I must tell you that this is an expensive procedure when it comes to time. So it takes a lot of time to have some results. It can take days, weeks, or even months to get a simulation. So now we're trying to explore how the use of artificial intelligence can help speed up the process. So a recent example of a fire in a room, I will give you an example. It would take up to 3 days in a normal computer, in an average computer that we have, not high performance computing or anything. And then using a trained AI network would take 1 second.
Wow, that's amazing. Can I get a system like that to help clean my house?
Definitely. I want one too.
It takes me a few hours a day now.
True
1/2 of
story.
a second, boom.
Done.
The AI vacuum cleaner and mop.
Yeah, but imagine that speedy transfer of information with first responders in a wildfire.
Yes.
So imagine if you just call me and tell me, okay, we have a fire, the wind is like, I don't know, 12 before, it's super humidity out there, vegetation is that. This is the map. These are the data. Can you tell me where should we head next in a couple of minutes or hours?
Yeah. And then, and so you wouldn't, in an ideal world, have to wait for the responders to tell you this, because there are sensors all over the world for, weather stations, satellite. The maps already exist.
Yeah.
So you could spot a fire from a satellite or from an Earth sensor or camera.
Yeah.
Right. You could pull up the local data. You wouldn't really even have to intentionally do any of these things, right? AI could be doing that for you and
Yeah.
alerting you about a fire, creating the spread prediction map, and then you'd send that to the local response team.
Yeah. I mean, there are risk maps out there. There are heat maps. We have huge access to geospatial data. We have development of sensors. And I mean, recently, the past 7 years or so, the European community has funded a handful of projects that have to do with fire management. So there has been many research groups around the world that have been able to combine knowledge from different fields, develop new sensors, and create a platform using various digital tools. So this is, I mean, the technological readiness level is not at its, we're not there
Right.
yet, but
Yes.
we're heading there, if that makes sense.
Yeah. Well, I would imagine, 10 years ago or 15 years ago, wildfires just weren't such a big thing, right? There wasn't so much focus on it. They weren't so destructive. And so the scientific community is kind of playing catch up on that area. Are there other areas of science that are more mature that you borrow from, like flood modeling, or some of the some softwares that were developed for similar situations that are being adapted to fire, or do you have to start from nothing on it?
We always use, first of all, yes, climate crisis has triggered awareness. I think also that wildfires is not a new thing. It has been there for ages. And the thing is that now we can feel its impact. And also there is more awareness, and people are realizing how wildfires can impact our lives, because we've seen some destructive events lately, which are really disturbing. So yes, a multidisciplinary approach is always useful. So it's important to combine applied, natural, and social sciences. So we need to talk to people. We need to understand whether they understand. We need to teach them in case they don't know what to do. And from an educator side, it's very important to communicate this science and all this information in simple words to people, and also make sure that first responders and fire engineers are aware of the physics. But it's a field that it's still evolving. Research is ongoing, and we can take ideas from different areas. I would say that, for example, risk maps generation can be are developed based on other disciplines and other catastrophes. But now with EFIS, for example, and with access to spatial data, Copernicus and all those resources out there, we have a focus on fires. So there are sensors involved, installed specifically to capture data related to fire. So emissions, humidity levels, and all of that. So yes, we're borrowing, and I think this is an attribute of a good scientist, to be open-minded, be ready to, receive information from others, know the limitations, and try and implement what it's been learned to the field.
Yeah, there are some areas where scientists should not be open-minded, and that's when people tell you, this research isn't going to go anywhere, focus on something else. No, Right. I'm sticking with this because I think it holds promise. Right. So persistence and stubbornness are also, I think,
Yeah,
good qualities. Right. And when your experiment failed 300 times, you're sure on 301 this time it's going to work.
yeah.
So
Resilience in research. Yeah. I
yeah.
mean,
So tell me about you talked about the importance of communicating your results and educating response communities about the physics that you're discovering.
yeah.
Um, how do you communicate that? And then how do you coordinate what you're communicating with research that's coming out of other universities and facilities? Are all of is everyone trying to communicate independently? And now the fire community is like, who do I listen to? Or are
Hmm.
researchers, do they collaborate about what they're going to communicate first and then put that out in one place, or is it just a big spaghetti bowl?
It depends. Okay, there are various levels on what you say here. So, for example, I will start from research-wise. I told you there are many research projects out there, but it's the first time that 2 years ago there was a project called Firelog, which is a European project that is actually cluster of projects and provides a platform for all the researchers and participants of like 6 or 7 big European projects to come together, exchange knowledge, and disseminate results. So for me, I was very excited when I saw this project. I thought that this was a step to the right direction because, things start from the head and we need to, we need to see some good guidance. So I think that was a brilliant idea and it seems to work. There are many international conferences on wildfires and wildfire management that facilitate communication between scientists because as scientists, sometimes we tend to be a bit cheeky, so not to support each other as much as we should. And this is inherited in what academia is. So there is competitiveness. So if funders will fund only one project, then you need to compete with all the rest. So that makes sense. So you know but I think that now with social media, so people start to be a bit more open and disseminating things. Um, Here at 𝐬𝐻, we organize many events. So we want to be a very open group. So we host monthly events and also we work with our students, we do workshops, and we try, last week we had an event with younger people, so from schools, that we did show them the fire tornado, for example, to show
Yes.
them how wind would affect the flame of the height of the flame. So, young kids were very interested in that. And I think it's good to try and address issues at all ages. And obviously, the thing that we can do is work with our local communities. So what we do here at 𝐬𝐻 is we have a very close relationship with first responders. So we do collaborate with the Lancaster Fire Rescue Services. So they do support us a lot. They do participate in all the events we are organizing and we do participate in their events. So there is a very good interaction between the groups and also with some other fire and rescue services. And with NFCC, National Fire Safety Council. So we do collaborate with the Institute of Fire Engineers. We try to disseminate our knowledge as much as possible to open access journal publications. So that's pretty much it, I think. Yeah, I talked.
Okay. So tell me from a practical standpoint, if you wanted to develop an AI system that could access the research of fire researchers and investigators, scientists all over the world, how would that AI system gain access to all of that information?
Well, there are already databases of that. So Science Direct or Scopus, so there are databases out there. The issue is whether research is published in open access or not. So this is another difficult point to tackle. And also there are reports out there that are freely, I mean, Institute of Society of Fire Protection Engineer or International Association of Fire Safety Science, they all have reports and they publish things that are available freely online. So I guess that, yeah, those databases have actually embedded search options that can allow you to have, specific keywords. So it can be done. Now, who process the data and what data are, useful and how you can combine them? This is another thing. So I have some colleagues that recently published a very interesting article. So they asked, I think, ChatGPT, what is a competent fire engineer or something. So, I do believe in humans, to be honest.
You believe in humans?
Yeah.
They're real. I've seen them.
Yes. So I believe that AI tools can be used, but with a supervision. So,
yes.
Yeah.
Right. Is the machine giving you something useful, or is it hallucinating?
Yeah.
Right. Yeah. No, it's newer than fire science, really. I mean, yes, we've had some degree of fire science, but modern fire science and AI have kind of grown up at the same time.
Yeah.
And they're equally youthful. Yeah.
And useful.
And useful, right. But you're saying that artificial intelligence is not a substitute for actual intelligence.
Right? If we assume there is intelligence.
Yes.
So, sorry, that was too bitter. But still,
there's more evidence against the existence of it.
Yeah. So, I mean, we should have a hybrid mode, I guess. So we should always make sure that we understand the physics. So as academics, we need to take a step back and assess the results that we use, the data that we use to feed the network. So the AI works like the neurons in our brain. We need to feed it data. It doesn't know the data. It doesn't care. So it's up to us as engineers, scientists, wildfire experts, whatever, to feed the AI with data that can be useful.
Okay, so we have to look at the quality of what's going in.
Yeah.
Right. Just like our brain, it runs on oxygen and sugar. It doesn't care what you eat as long as it gets that. But some of those things you eat are pretty bad for the rest of you.
Exactly.
Right? Yeah, it was very interesting. So when you said you were working with young people and bringing your portable fire tornado to get them interested, what age kids are you working with?
It depends because these are open events organized by our university. So we invite young people in, and our engineers. So the event that I did mention last week, it was presented by one of our undergraduate students, along with our technician from the lab. So it was very good experience for both of them, and for I think they were 12 years old. That were coming in that day. So they did design the experiment, they did present it. So it's very good for our students too, that they get the chance to learn how to present research and how to analyze results.
Yeah, that's so important, because you can only do as much research as you could do, and the same for your students. But if you get a whole new generation of people interested in what you do, they can take the work that you've done and they can advance it.
Yeah.
And that's so important to the progress of science, right? Is that someone has to inherit the work that you do. And so grooming those people with the lure of fire tornadoes and other things that
Or
kids are fascinated
bank
with.
box. They have a bank box here, so you increase
They
the pressure. Yeah, I haven't designed it, so it's part of the fire lab here. So just increase the pressure, and the cap goes up, the ceiling.
oh the yeah
Bank box, yeah. So that's
yeah
another thing that they use for showing children the effect of pressure and other things. So yeah,
right, and you get the cotton ball to burn up in the tube.
yeah,
Yeah, I love playing with that. I still love playing
yeah,
with that.
yeah.
That's great. So is there one area where you feel like the research has the fastest track towards practical application? That some of the research is basically to grow more academic information about it, and then some of it looks like it has applicability sooner. That you don't want to wait until the research is finished to start putting it into the field because it has some immediate life-saving benefit.
Yeah.
Where do you feel like the research has the fastest benefit right now to first responders or fire suppression teams?
I think that we should aim at having multidisciplinary research project with various partners from various fields, aiming at all stages of a wildfire, such as prevention, preparedness, response, and mitigation. Having both first responders, management people, the community level, and the scientists all on board, talking at the same time, exploring the use of new tools for training, such as AR or VR, trying to see from the technological part how we can implement early warning systems and how we can get access to that information very quickly, and then how we can, for example, implement safety in results in the design and the training of people, and how we can then communicate that information straight away to the communities. The problem is that each country has its own regulations, and I would say that there is not a uniform approach around the world. So another thing that I think it's very important is to try and explore what are the most efficient techniques, and how we can ensure that there is dialogue between countries. So, for example, US and Europe has different approaches, also different wildfires, to be honest. But because if we take the climate zones into account, the different vegetation, but in terms of management, things are not that different. So we can learn from each other. What is happening in Africa, or what's happening in we should try and facilitate this intercontinental communication. I think this is key, because here, if you see countries that are more impacted by wildfires, Portugal, Spain, Greece, Central US, China, those countries have developed more research on this topic. So there are the leaders. But I think that we should try and facilitate this dialogue and spread this knowledge all over the place.
Can you measure the spread of this knowledge with CFD?
Well, why not? But
conversational fluid dynamics.
So, you see?
There we go.
Appropriate abbreviation.
Right. Very, very interesting. And while the nature of fires might be different from country to country, that's simply because the fuels and the weather conditions or climate conditions are different. But the same physics applies no matter where you are.
Yeah. And imagine, countries such as United Kingdom, which were not that much affected by wildfires 30 years ago, are now entering wildfire season themselves. I mean,
Yes.
not the vegetation is totally different, but there are bushfires here, and there are some types of fires, and first responders are not familiar, so they enter new eras, and they need to catch up with the rest of. And this is just an example. In other countries, this is observed.
You said they're having bushfires in the UK?
Not only wildfires too. So there are other types of fires that they weren't that frequent.
Right.
If we compare with some years ago.
So do you divide the world like I do into two categories, places that are on fire and places that are going to be on fire?
Well, I don't want to have that. No.
But it's very important for people to anticipate this, right? Because I've spoken with communities and I said, hey, we're working on some new technology or something, that could be helpful for wildfire. And they say, well, we don't have wildfires here.
Yet.
That's not our problem. And then,
Yet.
then you 6 months, 9 months later, you read about that, they had a massive, 700 hectare fire, and they're completely caught by surprise because they don't realize that the conditions that favor wildfire are spreading, and the wildfires will follow.
I believe so. Also, unfortunately, there is a thing, multi-hazards is another problem of the future.
What is it? I'm sorry?
Multi-hazards. So multi-hazards.
Multi-hazard, yes.
Yeah, so that's another thing. Earthquakes and fire, floodings and fire, heat waves and fires. And there are many probable multi-hazard catastrophes that will occur in the near future. Especially not only impacted communities and the urban interface, but also more that can trigger technological accidents. So.
Right, you get a hurricane and it knocks down the power lines, and the power lines start a fire, and the trees all burn down, so the mudslides come in. And right, big, and then the mudslides block up the water intakes, and then the city runs dry, and then it can't fight the next fire. It's pretty exciting scenarios, right?
I think we're depressed now. I think it's getting very depressing now.
Well, you know what? The planet will still be here, and the cockroaches will still be here.
Good.
Right. So.
We live now.
Very interesting, and then fascinating speaking with you and learning about the research that you're doing. If people want to get in touch with you or access your research or your publications, what's the best way to find you?
Either via email or through social network. I'm very accessible, so just type my name on Google and you'll get the information from the page from 𝐿𝐸𝐿. So
Eleni Asimakopoulou.
Yeah.
Right. I got that right twice in a row. That's crazy.
Okay. Very well done.
Well, what I'll do is I'll put a link to your LinkedIn profile on our website when we publish this. Yeah. Thanks so much for joining us today. It was really very interesting.
Thank you for inviting me, Steve. And it's been nice to talk to you.
And continued good luck with your research. And that doesn't mean anything because luck doesn't give you research, right? Continued persistence with your research. And may a little bit of luck sprinkle in there too.
A little bit of luck for the funding is never bad.
For the funding, there you go. Yes. Great. Yes. Thanks so much for joining me. Well,
thank you, Steve.
Folks, you've been listening and watching The Fire Break. I really appreciate your time with us. You get some international travel right from your own seat and learn about what's going on in fire all around the world. Fire Break is sponsored by Team Wildfire. Check us out on the web at teamwildfire.com. Be well. Take care. Thanks so much.